Hello and welcome to this video. In this video, we will learn about summation of series and we will solve 10 problems as always. So, without further ado, let's get started. So, our first objective is to find sum of a series of squares. So, if you see this here, this means it is sum of 1 square plus 2 square plus 3 square up to n square. That is what this notation is, sigma notation. This is Greek letter sigma, which is sort of like E without the middle bar. So to find out this sum of square of numbers, we observe that I cube minus I minus 1 whole cube is equal to 3i square minus 3i plus 1. So now we take sum on the left side and sum on the right side. So we can write this as the right hand side as 3 into sum of I square minus 3 into sum of I plus sum of 1. Now if you look at left hand side, what happens is when I is 1, it will be 1 cube minus 0 cube. When I is 2, it will be 2 cube minus 1 cube. So 1 cube gets cancelled. When I is equal to 3, it is 3 cube minus 2 cube. The 2 cube from the previous term deleted and so on. So in the end, you'll be left with n cube. So left hand side is n cube is equal to 3 sigma I square minus, now we have to look at this sigma of I over here. This is equivalent to 1 plus 2 plus 3 plus up to n, and we know that sum of such a series is n into n plus 1 by 2. Now sigma of 1 would be 1 plus 1 up to n times. So this will be n. Now we keep it here. We take out this minus 3 into n plus 1 by 2 to left hand side, and n might also to left hand side, which gives us the desired result as n into n plus 1 into 2n plus 1 by 6. That is the sigma I square, where I varies from 1 to n. Now we want to compute sigma of I cube, where I varies from 1 to n. So proceeding like previous example, we have I to the power 4 minus I minus 1 whole to the power 4 is equal to 4i cube minus 6i square plus 4i minus 1. Now left hand side over here will become n to the power 4. I could have written sigma over here as well, but it's alright. I can also put a parenthesis over here. So ignoring that. Now right hand side will become 4 into sigma I cube minus 6 into sigma I square plus 4 into sigma I minus 1. So we have seen how 1 and I behaves. They will become minus n and 4 into n plus 1 by 2. Now sigma I sigma I square is, sorry for the horn, there was one vehicle going. I'm recording this at midnight and still people are honking. Now sigma I square we have just computed as n into n plus 1 into 2n plus 1 by 6. Now that will, the 6 constant is over here. Now we take out the second, third and fourth term to left hand side and we find sigma I cube is equal to n into n plus 1 by 2 whole square. Now we will also need to learn about a specific type of series called arithmetico-geometric series. This series is obtained by multiplying the corresponding terms of an AP and a GP. For example, if the arithmetic series is 2 plus 5 plus 8 plus 11 and so on, and the geometric series is x plus x square plus x cube, then you multiply the corresponding terms to obtain the arithmetico-geometric series 2x plus 5x square plus 8x cube plus 11x4 and so on. Now the question is, how do you find sum of such a series? So we let a1, a2 up to an be an AP, b1, b2 up to bn, this should be bn, be a GP. D is the common difference and R is the common ratio. Then sum would be AB plus A plus D into BR plus A plus 2D into BR square. Now notice that here A and B are first term, D is the common difference, R is the ratio, and so on. So we now multiply each term by R and write the first term, that is this term below this guy, the second term below third term, that is this guy. We pair them, and then we subtract both of these. We obtain 1 minus r multiplied with Sn is equal to AB plus dBr plus dBr square plus up to dBr to the power n, and minus a plus n minus 1 into d multiplied with b square. Now we solve all this to obtain Sn here, and S infinity can be computed if r is between minus 1 and 1, so that r to power n becomes 0. In that case, it would be AB by 1 minus r plus dBr by 1 minus r whole square. Now let's solve the problems, the 10 problems which we always solve in a video. Now, as always, I will say that do not look at the solution immediately. Rather, first try to work out the problem yourself. You should pause the video when the problem is being stated and then try to solve it. If you can't solve it, then you should come back and look at the solution. So problem number 1 says that find the sum of n terms of the series whose nth term is 12n square minus 6n plus 5. So we have this nth term given. Now sigma of n Sn, which is sum up to n terms, is equal to sigma I is equal to 1 to n Ti. Now Ti is 12 I square. 12 is constant, so it can be taken out of the sigma, minus 6n, that is 6i, 6 taken out, and 5. So we substitute the values for I square, I, and 5. So solving this for I square, the sum which we know, for I is the formula which we know, and 5 will become 5. So by solving this, we obtain the desired value as 4n cubed plus 3n square plus 4n. Problem number 2 says that find the sum to n terms of the series 1 square plus 3 square plus 5 square plus 7 square and so on. So here clearly nth term is 2n minus 1 for the AP 1, 3, 5, 7 and so on. So nth term would be 2n minus 1 whole square, which is 4n square minus 4n plus 1. Now it is only about substituting the formulas for I square, and this should be I square, not Ti square. I and 1, and we find the value is n by 3 into 4n square minus 1. Problem number 3 says find the sum to n terms of the series 1.2.3 plus 1.2.3, sorry, 1.2.3 plus 2.3.4 plus 3.4.5 and so on. Here nth term would be 1 plus n minus 1 into 1, that is n, multiplied with 2 plus n minus 1 into 1, that is n plus 1, and third is 3 plus n minus 1 into 1, that is n plus 2. So the nth term would be n into n plus 1 into n plus 2, that is n cubed plus 3n square plus 2n. Now we find the sum as sigma Ti. Here I have just written sigma n cube instead of writing sigma I cube, where I varies from 1 to n. So this is a shortcut notation to previous notation which you use. So sigma n cube plus 3 sigma n square plus 2 sigma n. Now we substitute the values for n cube, n square, and sigma n cube, sigma n square, and sigma n, and we solve this to get the result as 1 by 4 into n plus 1 into n plus 2 into n plus 3. Problem 4 says that find the sum of the series 1 into n plus 2 into n minus 1 plus 3 into n minus 2 plus up to n into 1. So here ith term would be I into n minus I minus 1, that is ni plus I minus I square plus I. Here n is treated as constant and taken out, and we have the sigma I and sigma I square and sigma I. So we substitute the values here and we find the result as n into n plus 1 into n plus 2 by 6. Now problem 5 says that find the sum to n terms of the series 1 plus 1 plus 2 plus 1 plus 2 plus 3 and so on. Here ith term would be 1 plus 2 plus 3 plus up to I, which is equal to I into I plus 1 by 2. So sum for sum of n terms, we take out half outside, and this becomes sum of I square plus sum of I. We substitute the value from the formula and we get the desired result as n into n plus 1 plus into n plus 2 by 6. Problem number 6 says that find the sum to n terms of the series 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on. Now here, first term has one number, second term has two, third is three. So nth term will have n numbers. So total number of numbers in n terms is n into n plus 1 by 2. Also, if you remove the bracket, the series can be written as 1 plus 2 plus 3 plus 4 plus 5 plus 6 and so on up to n into n plus 1 by 2. So sum is 1 plus 2 plus 3 up to plus n into n plus 1 by 2. So we can now substitute this in the formula. So it would be n into n plus 1 by 2 multiplied with n into n plus 1 by 2 plus 1. So we solve this and we get the desired result as n into n plus 1 into n square plus n plus 2 by 8. Problem number 7 says that find the sum of the series 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 plus 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 up to 16 terms. So here ith term would be 1 cube plus 2 cube plus 3 cube up to I cube divided by 1 plus 3 plus 5 up to 2i minus 1. So we solve this, we get ith term as 4i plus 1 whole square by 4. Now S16 is sigma I is equal to 1 to 16. We expand this and write it as I square plus 2i plus 1 by 4. We take out 1 by 4 common and substitute the formulas for sigma I square, sigma I and so on. We find the final answer as 446. Problem number 8 says that find 3 cube minus 2 cube plus 5 cube minus 4 cube plus 7 cube minus 6 cube up to 10 terms. So here ith term is 2i plus 1 whole cube minus 2i, this should be I whole cube, which is 12i square plus 6i plus 1. And now it's a question of substituting the values and finding the sum, which is 4960. Problem number 9 says that find 1 by 1 into 2 plus 1 by 2 into 3 plus 1 by 3 into 4 up to n terms. So here we can rewrite the terms as first term as 1 by 1 minus 1 by 2, second term would be 1 by 2 minus 1 by 3, third term would be 1 by 3 minus 1 by 4, and nth term would be 1 by n minus 1 by n plus 1. Now if you add all this, you see 1 by 2 gets cancelled with 1 by 2, 1 by 3 gets cancelled with 1 by 3, and similarly this 1 by n will get cancelled. So sum will have this 1, final sum will have this 1, and this minus 1 by n plus 1. So our sum of all terms is n by n plus 1. Problem number 10 says that find the sum of 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4 plus 1 by 3 into 4 into 5 up to infinity. So we let Tn is equal to 1 by n into n plus 1 into n plus 2. So we can write this as a by n plus b by n plus 1 plus c by n plus 2. So from the elementary system of equation, a is value of 1 by n plus 1 into n plus 2 when n is equal to 0. That is a is equal to 2. Similarly, b is equal to minus 1 and c is equal to 1 by 2. Now our nth term becomes 1 by 2n minus 1 by n plus 1 plus 1 by 2 into n plus 2. Now we write these terms here. Now if you look carefully, this 1 by 2 into 1 minus 1 by 2 and this 1 by 2 into 2 will not get cancelled. But okay, there is error here. This is wrong. This is wrong. So why this is wrong is, so this is 1 by 2, but this should be 1 by 3, this should be 1 by 4, not 2 into. So this is 1 by 3 and this is 1 by 4. Because our second term is 1 by n plus 1. So this should be 1 by 3 and this should be 1 by 4. Now, let us see what happens. This is 1 by 3. This is 1 by 2 into 3 and this is 1 by 2 into 3. So if you add this with this, it becomes plus 1 by 3, which will get cancelled with 1 by 3 over here. There will be 1 by 2.4, 1 by 2 into 4 in fourth term. So 1 by 2 into 4 and 1 by 2 into 4 will become 1 by 4. Now this is incorrect, which is actually 1 by 4. So this 1 by 4 will get cancelled with this guy and this guy together. So similarly over here, 1 by 2n will get and this 1 by 2n will become 1 by n, which will get cancelled by this guy. Okay. So what we are left with is this term and this term, and let me see, and this term also. So three terms over here will remain, and these three terms will remain. So there'll be a total of six terms which will remain. Everything else will get cancelled out. So now we have the sum, which is equal to 1 by 4 minus 1 by 2 into n plus 1 plus 1 by 2 into n plus 2. So sum of infinite terms would be 1 by 4, because this will become 0 because infinity in denominator, and this will become 0 for the same reason. So with this, we come to an end of our summation of series problems. Sorry, not come to the end of problems. We come to the end of video. There will be more problems on summation of series. And once summation of series is over, we will solve more problems on arithmetic progression, geometric progression, and harmonic progression, which will be more involving and will lead us to more concepts of problem solving. So if you have found this video useful, please subscribe to the channel and like my video, as it will motivate me to make more such videos. Thanks a lot for watching. Enjoy.